So let's take this as our first example. We have this configuration of four charges in a square. The sides are separated by zero point 0.1 meters, and we have same charges on the diagonals. And so from top left to bottom right, we have negative 4.15 millicoulombs, and from the bottom left to the top right, we have positive charge of 4.15 millicoulombs. So the magnitudes of all the charges are the same. Now the first thing that relationship that we can come up with, if we look at all of the charges and the distances, and we can see that they are symmetric. And so this allows us to make this statement. The magnitude of the force on charge 1 due to charge 2 is equal to the magnitude of the force charge 2 due to charge 1 is equal to the magnitude of the force charge 2 due to charge 3 is equal to the force magnitude force on charge 3 due to charge 2, and that's equal to the magnitude of the force on charge 3 due to 4, and that's equal to the magnitude of the force on charge 4 due to 3. And then the last two, magnitude of force on charge 1 due to charge 4, and the opposite, for magnitude of the force on charge 4 due to charge 1. So all those magnitudes are equal. And that's just the charges on the outer shells, or on the outer perimeter, how they're affecting each other. Now, the second thing we can look at is that since there is symmetry, there's going to be that symmetry in the diagonals. So the magnitude of force 1, 3 is equal to the magnitude of the force on charge 3 due to 1 is equal to the magnitude of the force on charge 2 due to 4, and that's equal to the magnitude of the force on charge 4 due to charge 2. So this lays out all of our forces. Now let's take and see if we can define the angles. So let's start on another page and let's make charge Q1 our center of our world. So we're going to have, this is Q1, we're going to place the x-axis along here through this charge, and the y-axis through this charge. And now, this is Q1. Now let's take, and I'm going to do these in a different color. Let's do it in light green. So I want to know which direction the force is going to be on this charge due to charge 2, 3, and 4. Well, charge 2 is opposite charge, so the positive charge is going to be attracted to it. So this direction we're going to call theta 1, 2. So this angle is the angle of the force on charge 1 due to charge 2. And for charge 3, it's going to be pushing away, so it's going to be in this back direction. So this is going to be theta, that's going to be theta 1, 3. And for the charge 4, it's going to be going straight along the x-axis, so it's going to be theta 1, 4. So I'm going to write here all of my different options here. So theta 1, 2, well, that one's pretty easy. That's just going to be 90 degrees, or pi over 2. Theta 1, 3, well, it's going in the opposite direction, and it's a square, so I know that this one part is 45 degrees. So then I'm going to start with a positive x-axis here. I'm going to go 180 degrees plus 45. So that's going to be 225 degrees. Or that's going to be 5 pi over 4. And theta 1, 4, well, that's just along the x-axis, so that's just going to be 0 degrees, or 0 radians. So now I've defined these angles. Now let's define for charge 2. And charge 2 is negative, so we're going to have a green dot here. And I'll have my x-axis, y-axis. So now, going to charge 1, that force vector is going to be in the downward direction. Need to change my pen here. And let's use, purple's a bright color. That'll be good. So that vector is going to be going down because they're attracting. And for charge 3, it's going to be attracted, so it's going to go along the x-axis. And for charge 4, they're going to be the same, so it's going to go back away from charge 4. And now we can define our theta angles. So this is going to be theta 2, 1, because it's charge 2 and it's the angle for charge 1. And then I'm going to have theta 2, 3 and theta 2, 4. So theta 2, 1, well, that's just pointing straight down, so that's 270 degrees. Or that's equal to 3 pi over 2. theta 2, 3, that's just 0 degrees. And theta 2, 4, well, that's 90, or I should say 180 minus 45. So that's going to be equal to 135 degrees. And that's just going to be equal to 3 pi over 4. So there's my angles for charge 2. I'm going to have charge 3. Don't want to forget this is charge 2. This is charge 3. And I'm going to have my x-axis. And y-axis. And I just realized that this is going to be in the way. So again, the forces on charge 3, well, for Q2, it's going to want to go towards each other. Q4 wants to go towards each other. And for Q1, it's going to want to go opposite back. So this would be defined as theta 3, 2, theta 3, 1, and theta 3, 4. And we can now write our angles down. Theta 3, 1, well, that's just going to be 45 degrees, or that's pi over 4. Theta 3, 2, that's just going to be 180 degrees, or pi. And theta 3, 4, and that's just going to be 270 degrees, or 3 pi over 2. And now we have our last charge. Get our x-axis here. The y-axis. So our force on this charge due to charge 1, they're going to attract, so it's going to move to the left. For charge 3, they're going to attract, it's going to move straight up. And for charge 2, it's going to repel. So I'm going to have the designations here. I'm going to have theta 4, 1, theta 4, 3, and theta 4, 2. So theta 4, 1 is equal to, well, that's just 180 degrees because it's going straight left, which is pi. Theta 4, 2, well, that's just going to be 360 degrees minus 45. That's going to give us 315 degrees, and that's just equal to 7 pi over 4. And theta 4, 3, well, that's just 90 degrees. It's just going straight up, and that's pi over 2. So now we've defined all of the angles that we need to be able to calculate the forces, and this will give us that we already know the directions now, right? We know the angles. So now once we get the magnitude of the force, we can convert this back into a vector for each of the resulting forces.